Hi everyone. Today we're going to discuss how to find the number of protons, neutrons, and electrons of an atom or ion. So the first thing I want to do is direct your attention to this diagram right down here. So you'll notice that there's two numbers. Now the first number, this 32, that's known as our atomic mass. And you'll probably know about these numbers if you've studied the periodic table before. Our second number is 16, and that is our atomic number. So it's very important that we note these two values as soon as we encounter a question asking us to find the number of protons, neutrons, and electrons. So let's start with discussing how we find the number of protons. So our number of protons is actually going to be equal to the atomic number. So as soon as you're trying to determine what the number of protons is, you look at the atomic number of the atom, and that is set as your number of protons. Our number of neutrons is a bit different. It's actually going to be our atomic mass, and we're going to subtract it by the atomic number. Lastly, our number of electrons is going to equal the number of protons, so we'll note that. But it's not going to only equal that, it's going to be subtracted by a charge if we have one. So this is what we encounter once we get ions. If it's not an ion, we won't need to worry about subtracting the charge, but if it is, then it's going to be something that we're going to encounter. So what we're going to do is try some examples that'll help you understand, and hopefully you'll be able to try them on your own at the end of the video. Now let's get started with the first question. Now this is the same sulfur atom that we encountered at the beginning of the video. So like we said, we have our value of 32 that represents our mass, and our value of 16 that is our atomic number. So generally the best way to lay it out is start with P, and we said that the number of protons is equal to our atomic number, so that's going to be 16. Our number of neutrons is going to equal 32, because that's our atomic mass, subtracted by our atomic number, which is 16. So 32 minus 16 equals 16. Now our number of electrons, we said that it's going to be our number of protons minus the charge. So as you could tell, this is neutral. There is no charge. So it's just going to equal our number of protons, which as we know is 16. So that's the number of protons, number of neutrons, and number of electrons for a neutral sulfur atom. Let's say we have a charge. Let's say we have a 2 minus charge. What's going to be different? So first we're going to start off with our number of protons. That's still going to equal 16. Our number of neutrons is also going to stay the same. So that's going to be 32 minus 16. And that's also going to be 16. Our number of electrons is what's going to change. Now remember at the beginning of the video, I said we would be doing, we take our number of protons and then we subtract the charge. Okay, so our number of protons we know is 16, and we're going to subtract. Now we have to look over here to our charge, and as we could see, it's 2 minus. So all you're going to have to do is in brackets write minus 2. And so let's say we get this. How would we do it? It would actually become 16 plus 2, because the two negative signs multiply to each other, create a positive. So our number of electrons is going to be 18. So overall, we'll have 16 protons, 16 neutrons, and 18 electrons. So that's our first question. Let's try a second one. So for our second question, we have a potassium atom and a potassium ion. So we're going to start off exactly like we did in the last one. We're going to begin with writing P. And we know that our atomic number is 19. So that's going to be our number of protons. Our number of neutrons is going to be our mass subtracted by the atomic number, or the number of protons, are the same thing. And 39 minus 19 is 20. Our electrons, like we mentioned, is the number of protons minus the charge. And because this is a neutral atom, there is no charge. So essentially, we're just going to get 19 because we can't subtract anything by it. Now, if we move on to the potassium ion, like we said, number of protons is going to be the same. Number of neutrons is also going to be the same. 39 minus 19 equals 20. And our number of electrons is what's going to change. So it's going to be P minus charge. So what does that mean? We have 19 minus, and then just do a little bracket. So what do we have right here? We have 1 plus. So just going to write it like this. 19 minus brackets plus 1. That's going to give us 19 minus 1 once we multiply them. And that's going to be 18. So our number of protons is 19. Our number of neutrons is 20. And our number of electrons is 18. So the main thing you always want to watch out for is, does the atom or the ion have a charge? Because that's really going to affect your number of electrons, and you just need to be wary of that. So we're going to try one more question, and for this one we have a phosphorus atom and a phosphorus ion. If you like, you could pause the video now and try it out on your own and see if you're able to do it. So we're going to start off like we always do. That's going to be our atomic number, which is also the number of protons. It's 15. Our number of neutrons is going to be our atomic mass minus the number, the atomic number. So 31 minus 15 is going to give us 16. And our number of electrons is going to be 15. And it's neutral, so it's going to stay as 15. We won't have to subtract for a charge. So moving on to our phosphorus ion right here, P is going to be the same. Number of protons is the same. Our number of neutrons is also going to be the same, so we're just going to do this. 31 minus 15 equals 16. Our number of electrons is, of course, going to change because it's an ion. So we're going to put our 15 for our number of protons, and we're going to subtract the charge. So looking right over here, we have 3 minus, right? So all we're going to do is put a bracket and then minus 3. What's that going to give us? That's going to give us 15 plus 3, and that is 18. So those are our final values. Just a quick note, sometimes in the periodic table, the atomic mass will often be a decimal number. A lot of the times, all you have to do is round up or round down to get the value. In an exam, you might actually be given the whole number anyway. You might not have to worry about it, just so that you know. I'd like to thank you guys a lot for watching. If you have any questions or recommendations for new videos that you might want, please let me know. Thanks.